Okay, what was the last problem in last class? What was the last problem in last class?
So we did finding the weight of the man when he's standing in the lift,
Achha, achha, achha. Okay, okay.
which is
I
going
think
with
I
some
told.
acceleration.
Correct. Man standing on the weighing machine, na, inside the lift.
Yes, sir.
Okay, okay. Then that part is over. So now Bhavya Yashasvi is joining again. She's already there, and again she's in the lobby. She's accessing from two devices. Huh? Bhavya Yashasvi. Okay, anyway, so now let us start today's class. Today's class is called as tensional force. Okay, so until now, how many forces we finished? Yashasvi? Until now, how many forces we finished? Yashasvi?
Sir, three forces. Sir, two forces, sir.
Two forces. What are they?
Gravitational force and the normal force.
Correct. Okay. So now third force is called as a tensional force. Very important. Tensional force. Okay. So tensional force will come into picture whenever there is a rope or a string. Okay. Whenever there is a rope or a string, whenever there is a rope or string, okay, or we can also say thread. Okay, so whenever we come across these two things, okay, these things, rope or strings or threads, then this force will come into picture. Okay, now for example, let us say there is a rope tied to a ceiling. Okay, loose. This rope is loose. Okay. And this is also rope, second case, which is tight. This is tight. Okay. Now this rope is loose, so therefore what you call it is also called as slacken. Okay, whereas this one tight, na, so therefore there will be tension. Correct or not? There will be some tension in this string, whereas in this there is no tension. So that means loose ropes won't have tension, whereas tight ropes will have what? Tension. Okay, so this is very important point, that first and foremost point is that loose ropes won't have tension. Loose ropes won't have won't have tension, whereas whereas tight ropes will have tension. Tight ropes will have tension. Okay, so this is the first point. Okay, next point. Suppose let us say there is a block of mass 10 kg, and then we have connected one string like this. Okay, this is slack. Slack means what? No tension. No tension. Now suppose the same block 10 kg. Now suppose there is a man. He is applying force like this. He is applying force. Okay. He is applying force. Then what will happen? The rope will become tightened. Na? Correct or not? The rope will be tightened like this. Correct? Okay. So when the rope is tightened, what will happen? This is the rope is tight. So that means what? There is some tension. Okay. So now the man is applying force like this. Okay. So what will happen? The block will move. the block will move like this. Okay, because of this tensional force, the block will move. Okay, the man is here. The block will move this side with some acceleration. Now tell me, man is applying force here, na? Man is applying force on rope. Man is applying force on rope. Then why block is moving? Tell me.
Sir, because
Why?
the rope is attached to the block.
The rope is
Attached to the
attached to
block,
the
so the
block.
force with which is
Correct.
moving will automatically move the block.
Correct. So that means when the rope is tight, okay, there will be, that means suppose you are applying with some force here. The same force will be applied here also. Correct or not? Here also there will be some force. Correct or not? Okay. So that means whenever the rope is tight, it means that there will be force at both ends of the rope. Correct or not? Here also there is some force. Here also there is some force. Correct or not? Here also there is force. Here also there
Yes,
is
sir.
force. At both ends there is force. So this is very, very important point. Okay. So whenever rope is tight, whenever rope is tight, there will be tensional force. There will be tensional force at both ends of the rope. There will be tensional force at both ends of the rope. There will be tensional force at both ends of the rope. This is very important point. Okay. Okay. So now I'll ask another question. Now, suppose this is the block, same block, 10 kg block, and this is a string. Okay. Now there is a man. Okay. Now I want the block to move this side, not right side. I want the block to move left side with the help of this man. Now, can this man, with the help of this rope, can he make the block to move left side? With the help of rope, can he make the block to move left side?
No, sir.
Why? Because this is a string, correct or not? Because this is a string. Okay. So that means this force which is there in the string, the tensional force is not pushing force, is not what? Pushing force. With the help of string we cannot push any body, rather we can what? Pull the body. So therefore tensional force is a pulling force. Tensional force is a pulling force. This is very, very important. Okay. Whereas normal reaction is what? Bhavya Yashasvi? Bhavya Yashasvi? She is not there. Huh? Bhavya Yashasvi? Okay, K Yashasvi, you tell me. Normal reaction force
So
is
it
what?
is a pushing force. It is a pushing force.
Correct. Whereas that means it will push the bodies. Okay. As I told you last class example. Okay. Bhavya Yashasvi asked that I'm confused about direction of normal reaction. I gave you the example. Two brothers
Yes, sir.
fighting or two sisters fighting, correct? They push each other, correct or not? When they fight, will they pull each other? No, no.
No,
Correct or
sir.
not? Two brothers can't pull, correct? It is only pushing force. So normal reaction is that one. Whereas here tensional force is what?
Pulling force, sir.
Pulling force. So that means with the help of tensional force, you can pull, correct or not? Okay. Are you understanding? Okay. So
Yes,
tensional
sir.
force, that means the tensional force is a pulling force. Okay. Okay. Now let us see next one. For example, let us say here there is a ceiling and then there is a string. Okay. This is a string. Okay. This is a string. This is a string and then connected to a block of mass 2 kg. Okay. Now what is now is this string loose or tight? Is it loose or tight?
Tight, sir.
Okay, Yashasvi, tight. When the string is tight, what will happen? There will be,
Tension.
so find the tensional force. Okay. So how to find free body diagram of 2 kg block? Free body diagram of 2 kg block. Okay. So that means this one. Okay. So what is the first force?
Sir, gravitational force.
Correct. That is equal to mg. Correct or not? Mg, m is equal to how much? 2. G is 10. So that means how much? 20 newtons. Okay. Anyway, mg. Now next here, what is the other force acting here? It is connected to string. Correct or not? Okay. Now just now I told that string, whenever there is a string in tension, yeah, whenever the string is tight, there will be force at both ends. Correct or not? Okay. There will be force at both ends. And now what is the nature of this force? Is it a pushing or pulling?
Pulling, sir.
Is it a pushing or
Pulling.
pushing or pulling? Pulling. So that means this string will pull. Pull means here there are two objects. Let us say this is object 1 and this ceiling we consider it as object 2. So it pulls towards each other. It pulls. So that means it pulls like this object 1 and pulls object 2 like this. Have understood the direction of this tensional force? Okay. It is a pulling force. Once you understand, now string is pulling this, it pulls the what you call block. So therefore the direction of tension force is upward here. And here at the point of ceiling, which is considered as object 2, it pulls. Pulls means direction will be downward or upward at the ceiling.
Downwards, sir.
At the ceiling, it pulls downwards. Correct or not? Huh? At the ceiling, what is the direction?
Sir, downwards.
Correct. So it pulls. Okay. So now here, what is the direction here? It is upwards. Okay. On this block, the direction of tension is upwards. So therefore, now the block is at rest. Rest means acceleration is 0. So F net is also equal to 0. Now tension T is equal to T minus mg equal to 0. So T is equal to what? Mg, which is equal to 20 newtons. So tension is 20 newtons here. Tension is 20 newtons. You understood? So therefore, I am going to write the properties of tensional force. Okay, properties of tensional force. Okay, what are the properties of tensional force? First and foremost, okay, it is a pulling force. It is a pulling force. It is a pulling force. Second property. Okay, what is the second property? Rope applies tension. Rope applies tensional force. Rope applies tensional force at both the ends. Rope applies tensional force at both ends towards itself. Towards itself. Okay, towards itself. You understood? So now here you can see towards itself or not. Okay, the rope is applying the tensile force towards itself. Now third point is okay, if the rope is massless, if the rope is massless, if the rope is massless, okay, force at both ends, force at both the ends is same. Okay, so now generally in our syllabus we have massless ropes. Okay, generally when we say rope it will have mass, but we neglect massless rope, or we can also call it as ideal rope. Okay, in our syllabus we have only this one 90. There are ropes which have mass, but they'll specify. Okay, but when they don't specify, we should consider the rope as massless, which means mass is approximately 0. So if this rope is massless, okay, then tension will be same throughout the string. That means if tension at here at this end is T, then at this end also it will be T. Okay, so therefore this rope is massless. The force at both ends is same. Very important. Okay. And the last point, fourth point is okay. Fourth point is tension is different in different strings. Tension is different in different strings. Tension is different in different strings. This is also very important. Suppose here only one string is there, so we took T. Suppose one more string is there down, then we should take it as T1. Some other tension. We should not take same tension. Okay. So tension is different in different strings. So all these points are very, very important. Please write down in your notes or in your formula sheet and revise. Not only for this force, but the properties of gravitational force and normal reaction force also you should write. Okay, these are very, very important. These are the basic concepts by which we can draw the free body diagram of blocks. Okay, only when you know the properties of these forces, then only you can draw free body diagram properly. Okay, so these are very, very important. So it is a pulling force and rope applied. First point, pulling force. Second one, rope applies tensional force at both ends towards itself direction. And third point, if the rope is massless, force at both ends is same. And fourth point, tension is different in different strings. Okay, so this is what okay, properties. Now let us see one simple problem. Find tension in both the ropes. Okay, there are two blocks, 2 kg block and 4 kg block connected to ceiling through ropes. Okay, this is rope 1, this is rope 2. Okay, so now they're asking us to find out tension. Okay, so what is the solution? First one is free body diagram. Free body diagram of 4 kg block. Free body diagram of 4 kg block. Okay, so how to draw free body diagram? Now, what are the forces acting on 4 kg block? Tell me, KSSV. First force, fundamental force is what?
So gravitational force, mg.
Correct. So it is mg. Next force, this is over. Now this block is connected to what? String, na?
Yes,
Correct
sir.
or not?
Tensional force.
Which direction? Now tensional force, this is one string, this is another string. Correct? Okay.
Yes, sir.
Tell me at this point, which side? At this point. This string, what
So
it will
towards
do? It will pull or push.
upper.
Correct. And for 2 kg block?
Downwards, sir.
Correct. So therefore, it is upwards. Let us say we call it as T. Then this is also T. Okay. Let us say we call T1. Let us say T1 because another string is there. Na? Here we call it as T2. Let us say. Okay. So this is T1. Now is the block at rest? Acceleration is 0. So F net equal to MA. M into 0, that is 0. So F net is 0 means what? Upward force must be equal to downward force. Correct or not? So T1
Yes.
equal to mg. What is m? 4 into g is 10. So that is equal to how much? 40 newtons. So T1 we got. Now how to get T2? Draw the free body diagram
Free
of
body
what?
diagram of the 2 kg block.
Correct. Now tell me what are the forces on 2 kg block? First force is what? from its
The
center.
gravitational force mg and two tensional forces.
Correct. Tensional force T1 is which side?
So downwards.
Correct. Then this tensional force, now this is also string, na? Now this is
Yes, sir.
also tension. Tensional force will be which side now? Here it is a pulling, correct or
upside.
not? This string
Yes,
will
sir.
pull these two, correct? So upwards. That is T2. Now is this block at rest or moving? Acceleration is 0. So F net equal to what? 0. F net is 0 means what? Upward force must be equal to what? Downward force. Upward, how many forces are there? Upward force, how many?
Only one, sir. T2.
T2. T2 equal to mg plus
mg plus T1.
mg is m is what? 2. 20. T1 we already got, correct or not? T1 is 40.
40, sir.
So 20 plus 40,
60.
Correct? Easy or difficult?
Easy only, sir.
Easy. Okay. Next problem. Find the tension in both the ropes. Okay. There is a 2 kg block. To that there are two ropes. One is left side, one is right side. Left side rope is making an angle of 60 degrees. Right side rope is making an angle of 30 degrees. Okay. Left side rope is making an angle of 60. Right side rope is making an angle of 30 degrees. Now find. Now are these ropes in tension or not? Are these ropes in tension or not?
Yes, sir, they are.
So there will be tensional force. So find the tensional force. Okay. So now let us see how to do that one. Okay. Now see here. Now suppose let us say if this is the 2 kg block. First force is what? First force on this block.
So gravitational force.
Which is
mg,
okay,
sir.
next.
20.
Now this now this rope, let us say this is rope 1, this is rope 2. Now rope 1 will pull, correct or not? Pull means what? This side, correct? Okay. So tension will be along this string like this, correct or not? Tension will be like this only, correct or not?
Yes, sir.
Correct? This is the tension. At what angle?
60 degrees.
60. Now other one. Now this is also string 2 is also what? Pulling only, na? So that means direction of force
Yes,
will
sir.
be like this, correct? It pulls. Okay. So that means this is how much? T2. This angle is how much?
30 degrees.
30 degrees. So now tell me, now here are these forces vertical and horizontal? No, no. T1 and T2. So we should resolve them. Okay. What are the components of this one? Tell me.
So T1 cos 60 and T1
This
sin
component.
60.
Correct. T1 cos 60 and this is T1 sin 60. Same way, what are the components of this one?
So it's same T2 cos 60 and T2 sin 6. Sorry, 30, sir. T2 cos 30 and T2 sin 30.
T2 cos 30 and this is what? T2 sin 30. Okay. So now if you draw the now only those four components, free body diagram of 2 kg block. Okay. Tell me what are the forces now? First force is what? Mg. Mg is 20. Okay. Now tell me what are the forces? This side force, upward forces are how many? Tell me.
So 2.
T1 sin 60. T2 sin 30. This side force is what?
So T1 cos 60 and T2 cos 30.
Correct. So T1 cos 60 and this side is what? T2 cos 30.
Cos
Correct?
30.
Now the block is at what?
Rest, sir.
So acceleration is
0.
Now in x direction. Now in x direction, f net equal to what? 0. Okay. Now left x direction means this one, correct? Left side force must be equal to what? Left side force must be equal to what? Right side force. Correct or not? Okay. What are the left side forces?
So
T1 cos
T1
60
cos
is equal
60
to
equals
T2.
T2 cos 30.
Correct. So T1 by 2 is equal to T2 into cos 30 is what? Root 3 by 2. So this implies T1 equal to root 3 T2. So this is equation number 1. Okay. Now tell me y direction. Tell me in y direction. In y direction also f net is 0. So in y direction also if f net is 0, upward force must be equal to downward force. Correct or not? Okay. What are the upward forces? T1 sin 60 plus T2 sin 30 must be equal to downward force is 20. Okay. So that is equal to, tell me, T1 sin 60 is what? Root 3 by 2 plus sin 30 is half is equal to 20. Now T1 you can substitute here. No? Okay, this is equation 2. Now I can substitute T1 here. So T1 equal to root 3 T2 into root 3 by 2 plus T2 by 2 is equal to 20. So root 3 into root 3, 3. So 3 T2 by 2 plus T2 by 2 is equal to 20, which implies 4 T2, that means 2 T2 is equal to how much? 20. So this implies T2 is equal to 10 newtons. Once you get T2, then T1 is equal to 10 root 3, because T1 is equal to what? Root 3 times of T2. So that's how we should find out T1 and T2. Okay, is it clear?
Yes, sir.
Is it clear? Okay. Next one. Find the tension in the rope. Will you do it as homework? Because after that I'll start next topic. Take down this problem. Find the tension in the rope.
Sir, it seems Bhavya is waiting in the lobby.
Bhavya. Okay. Find the tension in the rope. You can do it as homework. Okay, draw the diagram. Okay, mass is 2 kg, angle of inclination is 30 degrees. Or take a screenshot.
Yes, sir, noted.
Okay, next. Okay, next one is called as ideal pulley. Okay, pulleys means you already know. Okay, pulleys means previously in olden days they used to draw water from wells with the help of pulleys. Correct? This will be the pulley, and suppose let us say like this. There will be pulley here. A rope will be passed over that pulley. And here there will be bucket, correct or not? Okay, so suppose a man is there, he's pulling this one. Okay, understood? Okay, so this man will be pulling this rope, and then what you call, they'll draw the water from the well. Okay, so now here this is one string, complete string. This is a complete string passing over the pulley. Okay, so this pulley is also ideal. Ideal means what? Mass is approximated to 0. Okay, there is no mass for this pulley. Okay, so now here also what we'll do is, although this string is what you called is a one string only, just for understanding purpose, what we'll do is we'll consider this as one part and this as another part. Let us say this is AB and this is what BC. Okay, now just now I told that this string, now is it in tension or loose? This AB string, tension or loose? Is it tight or loose?
Sir, it depends.
No, he's pulling.
Then it is string tension, sir.
Correct. So that means tension. This rope will have tension. What will be the direction of tensional force? It's a pulling, na? So that means at this point it will be upward. At this point it will be downward. Okay. Let us say this is T. This is also T, because string is also massless. Now here also this is another. This is a BC part also. This is also string, na? So what it will do? It will also pull like this. And now this value is also T and T. Why? Because this is the same string, na? This is not two different strings. Are you understanding? Okay. So therefore this string therefore it will be like this. Magnitude wise, but direction wise is different. Okay, because of the nature, it's a pulling force. Okay, so like this we should analyze. Okay. So here we can always write down one point that okay, when ideal rope passes over ideal pulley, tension in the rope remains same. Tension in the rope remains same. It doesn't change. It doesn't change. It remains same. It remains same. Okay. So this is one important point. Now let us see one important point, very important. It's called as Atwood machine. Okay. So this is a ceiling. Okay. And this is one rope. Okay. This is one rope connected to pulley, and then this is a pulley. Okay. On this pulley there is one string like this. This is one string. This string is different from this one. This is string 1, this is string 2. Okay, there are two strings. Okay, these are completely different, two strings. So now to the other ends of this string, this second string, two blocks are connected, 2 kg and 5 kg. Initially they are at same level. We are holding it. Okay, now we released it. What will happen? If you release it, what will happen? These two blocks of mass 2 kg and 5 kg. What will happen? What will happen?
Sir, can you repeat the question once again? I have not understood.
There are two blocks, 2 kg and 5 kg. Okay. Connected.
Okay, sir.
Connected to this string. There is a string here like this, passing over the pulley. Okay. One string. Okay. Now initially I am holding these two blocks at the same level like this. They're at the same level. I am holding it. Now I released it. I released my hand. What will happen? What will happen to the blocks?
Like the heavier one would come down and the lighter one would be hanging in the upside.
Correct. Which one is heavier?
So the 5 kg block is downwards.
So what will happen? That one will go
down.
2 kg will go
Up.
Let us say it is going with an acceleration A. Okay. Now question is find the acceleration and tension. There will be tension or not in this string? Correct or not?
Yes, sir.
So find the acceleration and tension. That is the question. From here onwards, this is the common question. Find the acceleration and tension. So now what we'll do, first draw the free body diagram of 5 kg block. Tell me what are the forces. First force is what?
Gravitational force, sir, mg.
That is
And
mg
then
means 5t, 50. Next,
tensional
now
force.
this string will apply force at this point. Which side?
Upside.
Upward, correct? So upward. How much is tension? Now is this block at rest or motion?
Motion, sir, it's going down.
Correct. With acceleration A. So what is the equation? F net equal to M. Tell me the equation.
So 50 minus t equals ma.
M is how much? 5A.
Yeah.
Equation 1. Okay. Next, what is the free body diagram of 2 kg?
So gravitational force mg, that is 20.
Hmm.
And then tensional force towards upside.
Correct. Direction of acceleration?
Direction of acceleration is towards upside. So F net equals ma. T minus 20 equals 2a.
Correct. So equation 1, equation 2 equations, 2 unknowns are there. Correct? So if I add 1 plus 2 equations, TT will get cancelled. 50 minus 20, 30 is equal to 5 plus 2a, 5a plus 2a, 7a. So a is equal to how much? 30 by 7 meter per second. This is the acceleration. What about tension? How to get here? Okay, so T is equal to 2a plus 20. 2 into 30 by 7 plus 20. So how much? 60 by 7 plus 20. So 200 by 7 newtons. Okay. So this will be the tension. Throughout the string, this tension will remain same. Here also T, here also T. Okay. Everywhere it will be same. Okay. Is it clear? Okay. Is it clear?
Yes, sir. Yes, sir.
Okay. Now suppose let us say I have not given, suppose let us say for example, okay, for example let us say we take an Atwood machine. There is a string like this, there is a string like this, and like this. Suppose I have given masses m1 and m2. I have not given values. Okay. Now tell me how to find out acceleration. In which side it will move? Can you tell? Can we guess? Is it possible?
No, sir.
No. Previously we can tell definitely why.
Sir, because the mass was mentioned.
Correct. 5 kg is more, so therefore it will go downwards. Okay. Let us say here also, for example, let us say here also, by mistake, let us say you have taken 5 kg is going upward. Let us say by mistake you have taken 5 kg is going upward. If 5 kg goes upward, 2 kg has to go downward. Let us say. Okay. Now tell me what is the free body diagram here? This is how much? 50. This is tension. This is upward acceleration. What is the equation? Tell me.
So T minus 50 equals.
This is equation 1. And for this block, downward
It will be
20.
20 minus T equals 2a.
Correct. 20 minus T is equal to 2a. Now let us add these two. If you add TT will get cancelled. 20 minus 50 minus 30 equal to 7a, which implies a equal to how much? Minus 30 by 7 meter per second. Now you see previously how much we got?
30 by 7, sir.
Now also we got 30 by 7 magnitude wise we got correct only, na? Correct or not? But we
Yes,
got
sir.
negative. So whenever we get negative, we should think that our assumption is wrong. Here we assume that it is going upward, na?
Yes,
5 kg.
sir.
So that means it is going
Downwards.
downward. So same way, now also we don't know these masses. So what we'll do, we'll assume, let us say M1 is going
Downwards.
M2 is going
Upwards.
Doesn't matter, na? Magnitude wise you will get positive only, correct?
Yes,
Magnitude
sir.
wise you will get correct. Okay. So therefore we can always assume any direction, doesn't matter. If you get positive, our assumption is correct. If you get negative, our assumption is wrong.
Wrong.
Okay, now here tension will be there here. Okay, now tell me how to find out tension and acceleration. I want tension and acceleration. So what we have to do? Draw the
Free body diagrams.
free body diagram of M1 block. Now tell me, what are the forces?
So mg, m1g,
Mm.
and tensional force towards upside.
Mm.
The body is moving downwards. So m1g minus t equals m1a.
M1G minus T is equal to M1, equation 1. Okay. Next, what about free body diagram of block 2, M2?
So gravitational force will be m2g and tensional force towards upside.
Is it same or
Body.
not?
Yes, sir. It is same.
Tell me.
So it will be T minus M2G equals M2A.
Correct. Now two equations are there. Now I want acceleration. So I'll eliminate T. So adding 1 and 2. Left side, if we add this T will get cancelled. So how much I'll get? M1G minus M2G is equal to right side M1A plus M2A. Here I can take G common, M1 minus M2. Here I can take A common, M1 plus M2. Now tell me, what is the acceleration? M1 minus M2 into G divided by M1 plus M2. So this is the general expression for acceleration. To remember this expression, I'll tell acceleration A equal to difference in masses divided by sum of masses into G. What is the expression? Tell me, repeat.
So difference of masses by sum of the masses into gravitational force.
Correct. Previous problem, what were the masses?
So 5 kgs and 2 kgs.
So what is the difference?
So 3 by 7 into 10.
That means how much? 3 into 10 by 7. How much?
So 30 by 7.
We got correct?
Yes, sir.
So like you can calculate. Okay. Understood? So please remember this formula. Similarly, tension. How to get tension now? We have equations, na? Correct? So using this we can write. Now let us say from second equation. Second equation from second T equal to what? M2G plus M2A. So T equal to M2G plus M2 into what is acceleration? Here M1G minus M2G divided by M1 plus M. So that is equal to LCM is M1 plus M2. Now multiply M1 M2G plus M2 square G plus M1 M2G minus M2 square G. Now M2 square G will get cancelled. So that is 2 times of M1 M2G divided by M1 plus M2. So this is the expression for tension. This also you can remember it as 2 times of product of masses divided by sum of masses into G. Now previously what were the masses? Previous sum.
So 5 and 2.
So 5 into 2.
20 by 7 into 10.
2
30
into
by
5 into 2 into G is 10 divided by 7. So how much is 2 5s are 10, 10 2s 20, 20 10s 200. So 200 by 7 newtons. Previously also we got same. No?
Yes, sir.
200 by 7 newtons. So please remember these two results. What are the results? Acceleration is what?
So difference by sum into gravitational force.
Correct. Tension?
It is 2 into product by sum into gravitational force.
Correct. Very good. In this, what you called in the recent, I think NEET paper, they asked this question. Yeah. Are you able to see the screen?
Yes, sir.
This is a recent 2020 question paper, September 13th. Okay. Question number 39. Read. Can you read question number 39? Can you read question number 39?
Sir, I'm reading, sir.
You're reading, huh?
Sir, yes, sir. They're asking the acceleration.
No, I'm
Okay,
first read the question.
Okay, sir. Two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. So the acceleration of the system in terms of acceleration due to gravity is.
Tell me what is the answer? Use this formula. Just now I told you, difference in masses by sum of the masses. How much?
So
How
difference
much?
by masses by sum of the masses into gravitational force.
Into G.
Yes, sir, into G.
Tell me. Difference in masses is how much?
2, sir. 2 by 10 into 10 is just 2.
2 by 10 into G.
Okay,
G
we
you
should
keep
not
it like that.
substitute. Okay, fine. It is in the G. Yes, sir.
Hmm.
Sir, G by 5.
So answer option
4.
4. Easy or difficult? Tell me.
Easy only, sir.
Okay. Just remember that formulas. Okay. 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 So next one. After that, this one also you take a screenshot. Tomorrow you draw the free word diagram. Okay. These are for practice. Okay.
Okay,
And
sir.
then take a screenshot.
Yes, sir. Taken.
Next one is find the acceleration of blocks. This also you can do it. Okay. Actually, they won't ask this much difficult for you because just now we have seen they'll ask easy, but this is for practice. Okay. This also take a screenshot. Next, clamp force tomorrow I'll tell. By that we have finished some part of tensional force, and then remaining some other part is also there. Tomorrow I'll cover. Okay. Tomorrow I'll start with clamp force. Okay. So thank you all. Thank you very much. Okay. Any doubts?
Thank you, sir. No, sir.
Okay. So thank you very much. Tomorrow we'll meet at the same time, 8 o'clock. Okay. So thank you all.
Okay, sir. Thank you, sir.
Thank you.